Hi friends, in this video we look into what is a pass transistor and how this pass transistor is work. So generally a pass transistor is a series of transistors connected as shown here, right? So using these pass transistors we can denote or we can derive a logic as here X denotes A into B into C as they are in series, because we know that in VLSI design dot is series, this is series and this is parallel, right? Whenever the transistors are connected in parallel we perform addition, whenever they are in series we perform multiplication. So this is the pass transistor. Here I suppose 3 transistors are connected in series and I have given VDD as my input to a source, and here I connected output. My output is A into B into C. Now we will look into an example and see how this pass transistor is worked. So this is the example given. They have given 5 volt VD and they have given 5 volts for each of the transistors to the gate. They are asking to find out the voltage at P, Q and R. So before working on it, we will see 2 important points for working of this pass transistor. Suppose now these are, I consider the transistors to be NMOS, right? So NMOS, whenever my VD is greater than VT, my transistor is on. My transistor is on, right? Next condition is whenever my VD is greater than or whenever my VD is less than Vg minus Vt, then my source voltage will be my drain voltage itself. Okay, and whenever my drain voltage is greater than or equal to Vg minus Vt, then my source voltage will be Vg minus Vt only. We will see why it should be Vg minus Vt, right? See, consider here the example. So whatever are given is VD is given, it is 5 volt, right? And this is the gate, this is the drain, this is the source. Similarly for all the transistors. And gate voltage is given as 5 volt. Consider threshold voltage to be 1 volt. So these are the things we know, right? Now here Vt is the threshold voltage, right? So what is threshold voltage? It is the minimum voltage we apply for a transistor to form a channel, right? That voltage is called threshold voltage. And here my VD is 5 volt, and VT is 1 volt, and VD is greater than VT. This condition is satisfied. So I can say that the transistors connected are in on condition. They are not in off condition. Right? First condition is satisfied. Next condition is whenever my VD is less than Vg minus Vt, my source voltage is same as my drain voltage. But whenever my VD is greater than Vg minus Vt, it is the Vs voltage will be holding to Vg minus Vt. Why it is holding to Vg minus Vt? If even in this case also, if my VD equal to Vs, then this leads to Vgs less than Vt. You can substitute some values for these conditions, and you can see that whenever my VD equal to Vc, for this case my Vgs will be less than Vt, which indicates that my transistor is off. Transistor is off. That means channel has not formed, no current is flowing, right? But with this condition we have got transistor is on. This is the contradiction to the above statement. So for this condition to be not satisfied, we go for Vs equal to Vg minus Vt. These conditions satisfy this condition, so we follow Vs equal to Vg minus Vt in the second case. Now we'll go into the sum. Given that, now for the first transistor, for P, for finding P voltage, Vd is greater than Vt, that is for sure. So first condition is satisfied, right? Next condition is calculate Vg minus Vt. What is Vg minus Vt? It is 4 volt, right? And my Vd is 5 volt. Vd is greater than Vg minus Vt. That means this is the condition, right? This is second condition. So what should be my Vs? It should be Vg minus Vt. That is equal to 4 volt. This is equal to Vp. My voltage at P is 4 volt now, right? Now for Q, the same output of first transistor acts as input to the second transistor. So for the second transistor, what is my Vd? It is 4 volt, right? The same voltage is acting as this one. Now my Vg is 5 volt. My Vd is 1 volt, right? Now what is my Vg minus Vt? Is 4 volt. Vg minus Vt is 4 volt. Now here Vd is equal to Vg minus Vt. So again the second condition only. Okay. So what will be my output? Vg minus Vt, that is equal to 4 volt. But here this is Vq. Right? Now in a similar fashion, when we go for R, at R, now again what is my Vq? It is 4. This is acting as an Vd for last transistor. For Vg 5 volt and Vq is equal to 4 volt equal to Vd, Vt equal to 1 volt. These are the same conditions for as Q. So again my output Vr will be again 4 volt, right? So whenever I apply a 5 volt input at Vd and I apply the same gate voltages, and when I operate a pass transistor, my voltages at every instant will be 4 volt, 4 volt, 4 volt, the same voltage. What is the difference? Just Vt amount is discharged from the first transistor and it is continuing for the rest of transistors. This is how a pass transistor with a number of MOSFETs or number of NMOS transistors works. That's all for this video. Thank you.